believe we are on the last section of Chapter 1. As you've noticed, Chapter 1 in here is basically a review of a good majority of advanced math. There obviously is the unit circle with radians and degrees. Obviously this one has one small missing. 0 radians is not on there. So if you want to put 0 pi, that's fine. Know the degrees. Know the radians. Know the ordered pairs. It'll be very helpful. That's why we had the quiz the first day of school. Okay. I may come back to this particular page several times as we go through some of the problems. So here it says determine two coterminal angles, and I have specified, they don't have to be specified, but I have specified here that I would like one of them to be positive and one to be negative. Notice here, letter A, it's 110 degrees, so I've said give answers in degrees, and letter B, it's in radians, so I've said give answers in radians. Okay. So I look at it this way, coterminal. Well, terminate's kind of the root of that word, meaning end. Co, meaning that they basically end at the same place. So if we're at, say, 110 degrees, now I know it's not on here, but 110 degrees would be somewhere about like that, correct? 110 degrees? Think of it as almost a clock, where this one on the right here that's in standard position, this one doesn't move. Okay? So can you give me another one that if I kept going all the way around that I would end at the same place? You can do that. And what's the easiest way? If you're in degrees, what's the easiest way to do that? Yeah, just add 360 to whatever you've got. If you've got 110 degrees, just add 360, and you get, obviously. So if I were to tell you right now, go find where 470 degrees is, would you end up at that same place? You would. That's the easiest way to do that particular one. And then that's my positive answer, correct? I have given a positive, all right, because it's a positive 470 degrees. How about getting a negative then? Well, to get a negative, all you have to do is start there, go the other way, right? And then basically, if you're going around that way, you're not adding 360. Remember, that's the subtracting way around it, right? So subtract 360, so I'll fix that up here real quick if I can, without losing too much information. I did pretty good. So you subtract 360. Now that can get a little interesting. Because how are you technically supposed to do that particular math if you did it by hand? Yeah, you got to put the 360 on top, subtract the 110, and then just in, wow, that's a good 110. And just in your head, know that the answer is negative, right? So that's something that, if you think back to when we did decimals for logarithms in advanced math, that was a little rough period for some of you. So you subtract, and you have to just know the answer is negative. So I'm telling you, if I started basically right here and I went to negative 250, would I get to the same spot? You would. So negative 250. So have I met all the requirements of that problem? Well, let's find out. Have I given one positive answer and one negative? Yes, I have. Have I done it in degrees? Yes, I have. Are those the only two answers to that problem? No. There are infinite number of answers to that problem. Couldn't you just add 360 again? I mean, you could give the one that's way out there if you felt like it. You could just keep doing it. Or you could keep subtracting 360 and give an answer that's really far out. Okay? But I would say just keep with the simple ones. So now how about radians? Well, negative 8 pi over 9. Well, first thing, we should probably get rid of all this stuff on this page. Now, I know a lot of you right now are trying to remember how do you convert from radians to degrees. That's not what I want you to do. Do you agree negative 8 pi over 9, it's negative 8/9 pi, is just short of negative pi, correct? Not by much, right? Because 9/9 would be negative pi, right? So just have a general idea of where it is what I want you to be able to do. Now remember, negatives, you go around the circle that way. Positives, you go around the circle that way. So if we're going negative, right, so we're going out here, you agree it'd be somewhere over in there somewhere? It's not perfect, right? But basically that would be negative 8 pi over 9. So if that's where you're at, well, can we kind of use the same ideas we did on the last problem? If you want to get a positive answer, well, what are you going to do? You're going to add something to this, right? And how much are you going to add? Well, to get all the way around, you have to add whatever that is. Now, you can't add 360 degrees because we're talking about radians. So what is radians' version of 360 degrees? Yeah, 2 pi, okay? So basically what you do, and I'll do the math up here so you can see it, you are going to add 2 pi. But we're going to add 2 pi. We're going to make that a very special form of it so we can actually add, right? So we're going to make it, very good, 18 pi over 9, because that is just basically 2 pi in disguise, so that we can work with it. So now it is negative 8 pi plus 18 pi is 10 pi, and then over, good, over 9. Yep, you don't mess with the denominator, remember. So 10 pi over 9, whoop, hit it too many times there. So 10 pi over 9, well, that takes care of positive, and it is in radians, so we're good. But now, I want you to give me another one, and basically this time I want you to, yeah, just go around the other way, right? So you're actually going to be going, not that way, but that way, right? That's the negative direction. So in other words, just subtract 2 pi. All right, so really you can go back to this problem and then of course it's not that answer anymore. It is now negative. Yep. Right? Can we reduce that at all? Does that break down at all? No, that's about as good as we're going to do. So negative 26 pi over 9. Whew, wrong way again. Whoop. Whoop. There we go. Negative 26 pi over 9. Well, I didn't have to move the page. What was I doing? Okay, again, are those the only answers? No, they're probably just the easiest to get to. Now, the only time I see people getting confused on problems like this is if I start you at, say, 530 degrees. They say, hey, let's add 360, subtract 360, we got our answers. Well, if you add 360, that does give you an answer. But if you subtract 360, you agree you just get another positive answer? So if I started there, what I would do if I were you, see if this makes sense, subtract 360 to get your positive answer, and then subtract 360 again to get your negative. Does that make sense? I've seen people struggle, oh, it's not working. Well, you got to sometimes think through it a little bit, right? You have to subtract more than one time, or maybe add more than one time if they give you a huge negative, okay? Or maybe even add 2 pi or subtract 2 pi several times, okay? Any questions on that? It means it ends in the same place. Basically, I'm asking you to tell me how to get to the same place many ways, okay? Change each from radians to degrees. Now, realize back here, you've got a lot of conversion factors. You can use any one you want. I could use the fact that 360 degrees over 2 pi, as far as the unit circle is concerned, really equals what? As far as the unit circle is concerned, 360 degrees over 2 pi really means 1 as far as the unit circle is concerned. If you type that into your calculator, is it going to give you 1? No.
No, wait.
Basically, that's going to take 360 and divide by about 6. All right? That's how your calculator is going to do that. But according to this, that is 1. But is that the best conversion factor? Is that the one we kept using? No, we use this one over here, 180 in pi. And then you just have to decide which one goes on top, which one goes on the bottom. I don't know. That all depends. That always goes back to some of the science stuff you do. Cancel off the stuff you don't want. All right? So our conversion factor is some version of pi with 180, right? We know that those two, either 180 over pi or pi over 180, really, as far as the unit circle is concerned, means 1. Okay? And can you multiply by 1 anytime you want? Yes, you can. So here I've got 5 pi over 3. Well, what form of 1 am I going to multiply by? Well, I want degrees to somehow get into this answer, right? Now, do you normally have degrees on the bottom of something? No. And so you're going to put 180 degrees up here because I want the degrees to actually get in there, and it'd be really nice if that pi could go away. So if I do it this way, does degrees actually become the label of this? It does. And very nicely, now this doesn't always happen, but very nicely these pi's cancel off. And in fact, you can even do more. 3 goes into here once, 3 goes into there 60 times. So then you have to take 5 times 60, which is? And then on the bottom you have 1 times 1. So there you go, there it is. Now I started you with one that was actually on the unit circle so that you could have a, okay, is this working? Yes, it is. Now, is this a typo or something? I've got just a 1 sitting over there. Yes? Exactly. The pi has already been multiplied in. Right? So there is still a pi there, it's just you can't see it. And whenever that happens, you still do it the same way, because I look at it this way. I want degrees to end up in my answer. And you can say 1 over 1. But can I cancel pi's like I did back here? No, you can't. So here's where you have to rely on your calculator a little bit. This one's not going to be real pretty. Say, so you take 1 times 180, well, that's 180 degrees. And then just let your calculator divide it by pi for you. That's the best you can do. You can't cancel the pi. It's already kind of been multiplied in there like we were told. It does not matter if you are in degrees or radians when you do this. Great question. That's only when you start doing the trig, like sine, cosine, tangent. Then you have to be very careful. And just round wherever it says. We'll say tenths or something like that. Yes? Oh, you got it? Okay, what do you got? Now, do you remember in advanced math when I asked you that one time, where is the arc length equal to the radius? And that's exactly where it happens. That is 1 radian, 57.3-ish degrees. Okay. So that one's, it's on the unit circle, just not one that we talk about a lot. Okay. All right, how about going the other way then? Well, yeah, you switch your formula around, because now I would prefer that pi was in the answer and degrees were gone. So now degrees will cancel. They'll be out of there. Okay, and so basically we're talking about 70 pi over 180 because the degrees have canceled, right? One on top, one on bottom. And then obviously this goes to 7 pi over 18. If you kind of cross off the zeros, can we do any better? I don't want you to round it all. We'll say these in terms of pi. I would almost always prefer them that way if it's not specified that way. So 7 pi over 18, are we going to do any better? No, that's as good as we can do. Now, what's the difference between this letter B as opposed to the last one we had? It's a very subtle difference, but it's very important. The degree symbol. Back here, you can't just start assuming that's degrees. If it's just a 1 and there's no degree on it, it's radians. Right? And here, 1 degree. So you can do the same thing. Again, don't ever try typing pi over 180 in your calculator and having it tell you 1. I mean, it's not going to. Right? That's not how it's used to calculating. So their degrees are gone. Can we do any better? Yeah, 1 pi over 180. And remember what that really means, pi over 180, right? That means you take pi, which is from there to there, divide it up into 180 even spots, and you've got one of them. Okay, so if you divide this up into 100, you agree that's about 1 degree, maybe right about there? If you divide that up into 180 little pieces? Yeah, I think it probably is. All right, where are we at? What's next? Oh my goodness, here we go. Determine all 6 trigonometric functions for the given angle theta. That's a pretty nice picture, though. You gotta admit, that's pretty nice. You don't have theta on yours? No? Well, you do. Well, put it on there then. No, this basically, yeah, this is physics, big time. Now, when you were in advanced math, I told you to always make a triangle, make a right triangle, but always make sure you connect it to the x-axis. Okay, so if you're right here and you got to connect that point to the x-axis, you just go straight on up. There's your right triangle. Again, I'll trace it more in red for those of you that might not see it. And basically, you know that this much is 8. You know this much is negative 15, correct? I think some of you, when we had the previous class, missed out on some negatives. And you found out if you start doing that, problems occur, and you get a lot wrong. But remember, there's one number for sure that will never be negative, and that's the hypotenuse. Because the hypotenuse represents a distance. Right? So does anybody remember this triple? I stick with triples. Well, I'm just saying the Pythagorean triple. 8, 15, it is 17. Now, let's say you didn't know that. You could go back to Pythagorean theorem. 8 squared plus negative 15, that's a really bad 5, equals c squared. It works out. So now what we have to do is actually remember where theta is. And in this one, theta is always going to be closest to the origin, as close as you can get, right? So that's actually where you can put theta, as far as this is concerned. Now let's see if you can remember the 6 trigonometric functions. Give me one. Sine. Cosine. I heard it. Give me another one. Yes. Cotangent. Ooh, getting them out of order. Here we go. Cotangent. That's all right. Doesn't matter what order we're doing them. Tangent. It's not. You're not going to see the other two. Yeah. Secant. And cosecant. Yeah, this is not normally the order that we look in them, but we're so smart we can handle it. Yeah, SOHCAHTOA is a great place to go because you got a right triangle. It's a perfect idea. So let's just do sine, cosine, and tangent first because those are the ones that come from SOHCAHTOA. And once you get those three, the other three are just the reciprocals of those answers. You just have to know which one goes where. Okay. So sine then, according to this, is opposite over hypotenuse. If we're talking about that angle, this one over here, this negative 15 is opposite. This one's hypotenuse, leaving this one to be adjacent. All right. So if you do sine, it's opposite over hypotenuse, and so it is negative 15 over 17. Are you in agreement with that? Any questions on that? All right. Cosine then, according to SOHCAHTOA, is adjacent over hypotenuse, which is 8 over 17. And again, we're going to go down to tangent next, which according to this, opposite over adjacent, so negative 15 over 8. And I should probably put that in the right spot. Now, the easiest one to remember is which one is the reciprocal of tangent, and that's cotangent. And all you really have to do, because it's just 1 over whatever tangent is, but 1 over that just means flip it over, right? And so the nice thing is, though, is that negative, I'd normally just keep it in the numerator. Okay, because remember, it's your job when you draw these pictures. If there is a negative, it's your job to figure out which one's which. It's going to tell you which quadrant. Okay, and you got to decide, oh, is it this one, the x value, the y value, which one's negative? Now, who remembers which one goes with secant? Yes. Cosine does exactly. The easiest way to remember is it would have been way easier if secant went with sine because they'd both be s's. But of course, they didn't do that. Right? So you got to remember that secant goes with not the one that you think it should, but with the other one. And so it goes with cosine, so all you got to do is flip that one over. And see, the rule still applies. It'd be great if cosecant just went with cosine. It makes the most sense, but that's not how they did it. Okay? And so the c goes again then with the s, and so it is 17 over 15. And notice, I still put that negative on that numerator. Do you have to know? Do which one you're comfortable with. But remember then, if I tell you some information about that, you need to figure out what part of it's negative. And remember, the easiest way is hypotenuse, never negative. Any questions on that? All right, we're doing good. So I'm telling you to determine secant if sine is 5/8. So can I just, flip that over, or? I could probably draw a triangle. Now, sine of theta is positive here. It's a positive 5/8, correct? So where is sine positive? Which two quadrants? And we'll go back. Sine is the y value, right? So where is sine positive? 1 and 2 is correct. Do I know exactly where this one has to be drawn? First or second? Does it say? No, so we'll just pick one for now, but we'll keep that in mind. So just put something off into the first quadrant. Right? And then, of course, you're going to connect it to the x-axis because you've been told over 100 times. Theta goes there. So now you have to put in sine, which is, again, if we go back to SOHCAHTOA, opposite over hypotenuse. So which one's opposite? Spot with 1 dot, 2 dots, or 3 dots? Yeah, 1 dot. All right. Okay, so it's 5. The 8, hypotenuse or adjacent? So up here. Agreed? Now I'm being asked for secant, so I should probably look for the one that goes with secant, so I should look for cosine. And if I can find cosine's answer, I can just flip it over, right? Do I know cosine yet at this time? No, I need adjacent. If I had adjacent, I'd have it, right? Okay. So how are we going to find that? Well, yeah, we'll just call this, I don't know, what do you want to call it? A? I don't know. A. So A squared plus 5 squared equals 8 squared. Solve for A right now, please, if you haven't done so already. I'd say leave it as a radical in simplest form. Okay, I've heard plus or minus quite a few times. Now we have to decide, does that make sense in our problem? Based on what we know, does plus and minus both make sense? Why? Okay, not what I'm looking for. It could be in the second quadrant. Thank you. If I draw it over here, is that going to be negative? And isn't it still going to be the square root of 39? Now, if I told you for a fact it was first quadrant without a doubt, then it's only the positive. Okay? But now we see the math did it for you. It put both answers in there for you. It's your job to figure out, do I need them both? Do I need just the positive? Do I need the negative? So very good. But is just positive and negative square root of 39 your answer? No, that's the answer for that. Now we still have to find secant eventually, but we have to find cosine first, and some of you see what's coming here. All right. So find cosine first, which is adjacent over hypotenuse. So it's positive and negative square root of 39 all over 8. With that, we're not quite to calculus yet, though. This is review of advanced math. No. We're not quite to the calculus where you can leave radicals in the denominator yet, so we'll have to fix this. Well, what is secant just if we were to leave it? Okay. Now, we do have to take care of this problem. Yes. Yeah, funny form of 1 is kind of what we've referred to it as for years, another Starkleism. But it's technically called the conjugate, okay? And so what you have to do... Now, do we know the answer is going to be positive and negative at this point? So you can stop writing it and then just write it at the end. But it's up to you. Because let's face it, there'd be positive and negative on all these. So if you take positive times negative, you still get both positive and negative in the end. So it's up to you. So we get 8 square root of 39 over 39. And just throw the positive and negative out front. There it is. Yes? Conjugate? Say that one more time. I'm sorry. Oh, okay. Great question here. Everybody pay attention. The question is, can the plus or minus go in here in between the 8 and the square root of 39? It cannot, because that is a different answer. This is multiplication right here, not adding and subtracting. It's not 8 plus or minus the square root of 39. You're thinking more along the lines of quadratic at that point, and that's not how it works. And we only have one last problem to do. But this is a pretty extensive review of advanced math. Solve for x and y. It's a right triangle, so it would be awesome if we had one more side, because then we could just use Pythagorean theorem, but we don't. We have a lot of ways of doing it. Law of sines is probably the most popular, because in law of sines, what do I say you need? You need a pair. Do we have a pair? We do. We have an angle on the side opposite. You can just still use SOHCAHTOA and set it up, but you can just do law of sine, so it's sine of 90 over 15. Now, in doing law of sines, you were told to be very careful. In this problem, it doesn't make a difference here, but you have been told, do you agree that'd be 50 up there? You have been told, again, this one doesn't make a difference, but told to pick the smallest angle next, because then sine can't possibly give you that wrong answer. Remember, sine can be possibly an obtuse, and then it gives you the, all right, and it gives you problems. So I would go with sine of 40 then, over, well, which one is it paired with? It's paired with x. Okay, this is law of sines, basically, you know, in a quick review. And now is when it matters what mode you're in, because we are taking sine of something. Let's face it, sine of 90 we should all know. It's just 1. All right, so really we don't have to worry about this particular, because we know it's 1. So otherwise you would cross multiply and then divide, right? But I think we know we're just going to divide by 1. So take 15. Now what mode should you be? Degrees, because it's 40 degrees. We were just, you know, making sure you were on your toes there. So take 15 times the sine of 40 degrees, make sure you're in degree mode, and that should tell you approximately the size of x. Are we expecting more than 15 or less? Yeah. Because this has to be the smallest angle, or the smallest side, because it's across from the smallest angle. And does anybody have that particular answer yet? 9.64. Yeah. Is that what you got? Does it say in the directions where to round or anything? So yeah, hundredths is good then. So now here's where I have a slight problem. Could you technically use Pythagorean at this point? Yeah, you got two sides, but when you square an error, because you rounded that, when you square an error, you make the error worse, right? So it's probably not a good idea to do that. You could. It's going to still come out pretty close. You know, but what I would do is probably just go back to law of sines and get the other one. Because at this point, you'll know if the calculator gave you the wrong answer. Right? You'll know, hey, wait a minute, that can't be right. But again, this one you don't have to worry too much. Again, this is just 1 because we know that. And so you just take, now we're expecting y to be bigger than 9.64 or less? A little bigger and obviously less than 15. Okay. And I would say probably a lot closer to the 9.6 than it is the 15, just based on the numbers. Okay. I wouldn't say, yeah, much more than that, x, is it? Does anybody have that? 11.5-ish, something like that. 4.9, whatever, you know, whichever way it rounds. And I bet you if you try Pythagorean theorem on that, it's going to come close. It might not be perfect, but it will still get pretty close. Okay, so any questions on that? You know, pretty extensive review of trigonometry.